Humans have been exploring the stars for ages, and while we don't have a lot of extraplanetary travel and exploration under our belts, we, collectively, have learned a thing or two about what to consider when designing a spaceship. Since no planetary sci-fi world building is complete without at least one spaceship, I thought it would be interesting to explore the current considerations involved in space travel. Hi, I'm Casey Hudson and I write sci-fi novels. Get to know the real-world creatures, technology, and planets behind my books as I walk you through the tangential science of my worlds. For NASA, spaceship design is a 5-step process from concept to construction. Designers look to understand the purpose of the space vessel, design it to that purpose, and analyze whether the proposed design will endure. From there, testing and building bring the spaceship into existence. For those of you who are not aware of how nuanced space missions can be, NASA shares a list of 8 mission types that robotic spacecraft commonly perform. Anything from orbiting a planet for generalized data collection to measuring the atmosphere or surface makeup are common space missions. In order to serve their missions, spacecraft must have some basic equipment and leave our planet. So what does the everyday spacecraft need? One of the biggest challenges in spacecraft design is the balance between weight and durability. The craft must be light enough to leave Earth's atmosphere, but it also must be durable enough to survive harsh environments in space and on other planets. When creating this balance, designers must also be mindful of the essential considerations of a spacecraft that help it leave Earth and complete its mission. These include propulsion and thrust. Can the craft escape Earth's atmosphere and maintain orbit? Can it propel itself to a destination beyond our planet's lower atmosphere? Through space? Power. Does the craft have enough charge to get where it's going, and back if need be? Navigation. Can the craft maintain direction and course? Communication and data handling. Can the craft share data and communicate with ground control? Thermal management. Can the craft withstand the various temperatures of space and atmospheres? Can it endure entry into another planet's atmosphere and land safely? Environmental considerations. Will the craft survive the various temperature, radiation, vacuum, microgravity, weather, and chemical realities of its mission? When thinking about communication and data handling, it is important to remember that many of our current spacecraft are robotic and need to send data back to Earth. So these systems must be designed with the ability to transmit while withstanding interference from other sources of radiation. Most recently, too, sustainability considerations have become a focus to ensure that future space junk is minimized. There's a lot to think about when there's life on board a spaceship. Some of the concerns already mentioned are also crucial for human survival. These, of course, include thermal and environmental control to ensure that the onboard environment does not become too hot, too cold, or too radioactive for life. Additional systems to live and breathe on a spaceship, including carbon dioxide removal, humidity control, and fire suppression. And you can't forget food, water, and toilets. And if that weren't enough, remember that a spaceship is a closed environment with recycled air, water, and waste. Systems for ensuring cleanliness are imperative for long-term survival in an environment where microorganisms transfer more easily than an open Earth environment. Oh, and one more thing, space travelers have spacesuits that are designed to maintain life for days in case there is a catastrophic ship failure. It is also important to ensure quality of life on a spaceship. Some particularly concerning hazards of space travel are isolation and confinement. Being in a confined space with the same people for months, even years, can be taxing. Further, living and working in the same place with little or no support from ground control means that the professional and psychological training needed for a space crew is extensive. For some time, increased physical space inside the craft for crew comfort as well as exercise equipment to combat bone and muscle atrophy, have been part of space explorer life. More recently, workload management and light therapy to maintain circadian rhythms have been added to ensure well-being. Whew, that's a lot to take into account for any individual space vessel, but thankfully, astroscientists continue to fine-tune their craft. Considering how quickly astroscience evolves, there may be even more essential spaceship elements by the time I finish this sentence. I may even have to do an update to this talk in a couple years. Either way, I look forward to seeing space travel evolve. Think there's a crucial space design factor that I forgot? Know of a common factor that I should have mentioned? Share your thoughts in the comments below. Until next time, stay curious.